Friends, my name is Manoj Chaudhary and welcome to today's session on applications of derivative. And in this session we will cover how to find maxima and minima function using second derivative, and it is also called second derivative test. So let's see how a second derivative plays a role in finding maximum and minimum value of the function. So here let's understand first of all how a maximum and minimum function forms. So if a function is maximum, then first of all, it's in first section, its graph you will observe is in the increasing form. Then this is called stationary. There is a variety of name to this particular point. We say it's a stationary point, or we say it's a extreme point, or even we can say it's a turning point. And then after increasing section of the function, the graph goes on decreasing. And if you observe this entire graph, so you will observe this is nothing but a maximum point of that function. Then what if it is a minimum function? So in case of minimum function, so you will observe first it will be a decreasing function, then you will reach to this extreme point or stationary point or turning point. There are so many names to this particular point. Different textbooks use the different wording for this point. So after the first section, which is decreasing, you will observe that it goes on increasing. So in the first graph, how a maxima forms? In first section, you will observe the graph is increasing. So it's increasing. Then this is a stationary point or point of maxima. We can say this is the point of maxima, where the maximum value of the function occurs, and then the graph starts decreasing. So the thing is, there are three sections of this curve. In first section, you will observe it is increasing, then point of maxima, and then it's a decreasing function. In case of minima, while it is exactly opposite, in first section of the curve you will observe it is decreasing, then this point of minima. So let's mark this as point of minima. So this is the lowest point of that graph, and after that you will observe it's a increasing function again. Then and then only minima occurs. So here we have to study a second derivative test to analyze the maximum and minimum value of the function. So there are actually two things that we have to study here. First, we have to find a point where extreme values of the functions occurs. Means extreme means it may be maximum or minimum value of the function. And second thing is, after that we have to find a maximum and minimum value of function also using second derivative test. So let's see one by one what are the steps to follow in second derivative test. So here I am writing the steps to find maxima and minima using second derivative. So the step number one is, so before that, so let's say they will provide you a given function. So friends, this is given function y equal to f of x. So then the step number one is, your job is to find its derivative. So we can say y dash or f dash of x. So quickly find out the first derivative, and in step number two, equate that first derivative equal to 0. So what is the reason? So what do you think? What is the reason why we equate that first derivative equal to 0 for maxima minima? So please observe in the graph whether it's a maxima or minima, what is happening at that extreme point. So I'm talking about this extreme point. So this is the point of maxima. So here at this point of maxima, we already discussed this concept in my previous videos. If you draw a tangent that tangent is exactly parallel to x-axis, and whenever a tangent is parallel to x-axis, so no slope exists, means slope of tangent is 0, means derivative is 0 at that point. So right, so let's say this is nothing but the point C. I am marking this as point C. So at point C we say the derivative is equal to 0. So at point of maxima you will observe the derivative equal to 0. The reason is the concept slope of tangent is equal to derivative, and in this case if you observe this tangent is parallel to x-axis and ultimately derivative becomes 0. Okay, so what about a minima case? So if you observe this is the point of minima, and if you draw a tangent at this point, so this is the tangent which is drawn at point minimum point, you will observe that tangent is also parallel to x-axis. So friends, what is your observation? Whether it's a maxima or minima, you will observe a tangent drawn at maximum point or tangent drawn at minimum point are always parallel to x-axis. Therefore, in this case also you will observe the slope of tangent is 0. Ultimately, slope of tangent 0 means derivative equal to 0. To understand this thing, you must know this basic fact that derivative is nothing but the slope of tangent. This is a very important concept that we already discussed in my previous video along with the proof. So I hope every one of you remember this thing. So derivative is nothing but the slope of tangent, and in this case tangent is parallel to x-axis, therefore the derivative is equal to 0. Whether it is a question of maxima or it's a question of minima, you will observe that tangent is parallel to x-axis and derivative is always equal to 0. So at point of maxima or minima, so whether it's a question of maxima or minima, you will observe this thing every time, the first derivative equal to 0. And friends, if you equate this first derivative equal to 0 after simplification, so here I am mentioning the step number 3, or after simplification of this equation, you will get a variety of values of x. So let's say the first value of x we got is x equal to a, or second value is, let's say, x equal to b. So first of all, equate the first derivative equal to 0, and after equating that equal to 0, simplify the given equation and you will get one or two values of x. So might be you will get a one value of x or two, or maybe sometimes you will get three values of x, but at the most max in your examination you will find other one or two values in final paper. So right, so let's consider after simplifying this first derivative equal to 0, we got these two values of x, that is x equal to a and x equal to b. Then since the name suggests it's a second derivative test, so friends, this is the important step, second derivative test. So here, since f dash of x is already ready with you, so differentiate it one more time. So differentiate that one more time and find out the double derivative. And as the name suggests, the double derivative test, the double derivative or the second derivative decides where exactly the maxima or minima of the function occurs. Since we have two options, either x equal to a or x equal to b, so we don't know where exactly maxima or minima is there. So who will decide where exactly maxima or minima occurs? So second derivative. That's why the name of the test is second derivative test. So as second derivative decides where exactly maxima or minima occurs, your job is to substitute this x equal to a in double derivative, right, and find out the value. And let's say that value is less than 0. I'm assuming, let's say you will get either a positive value or negative value. So let's say whatever the value that you got is negative. So, and for x equal to b, so here let's say the second case is we have two values of x, a and b. So let's second case is x equal to b. If you substitute that in the double derivative, you will get a certain value, and I'm assuming that let's say it's greater than 0. So now Here, if you observe, if a second derivative, this is a very important discussion. So please, I request everyone, please focus over here. If the second derivative is less than 0. So friends, less than 0 means negative, like a -5 or -3. If the second derivative is negative or less than 0, then the conclusion is at x equal to a, function is maximum. So this is the conclusion that you have to draw from this. If the second derivative is negative, then we say at x equal to a, the function is maximum or maxima occurs at x equal to a. This is the conclusion. Then if you substitute x equal to b and the value is positive like a +5 or +7. If a value is positive, then the conclusion is at x equal to b, we say f of x is minimum. So right, so at x equal to b, we say minimum if the second derivative is positive. So friends, here this is a very important step number 3, that you have to observe it carefully, because on the basis of the second derivative we decides where exactly maxima and minima occurs. And the rule is, if the second derivative, please observe, if the second derivative is negative, then we say a function is maximum at that point x equal to a. And if the second derivative is positive, then we say the minima occurs at that point x equal to b. So right, so means it's a little bit contrary. So if a value is negative, then maxima occurs, and if a value is positive, minima occurs. So please observe this thing. Then the step number 4, in step number 3, now we know where exactly maxima or minima occurs. Means we know at x equal to a, function is maximum, and at x equal to b, function is minimum. But the real question is, what are the maximum and minimum value of function? So maximum and minimum value of function. So we also want maximum and minimum value of function. So how to find that? So just write down the given function again. F of x, I am talking about this given function. So y equal to f of x, which is given in the first step itself. So start with that function and substitute this x equal to a in that function. So you will get a value of that function. And since at x equal to a, maxima is there, means whatever the value that you are getting at the end is a maximum value of function. So we say whatever is the answer is a maximum value of functions, right? So this is the maximum value of the given function. Then if you substitute x equal to b in the same function, then it's a f of b, and we know at x equal to b, the function is minimum, means you will get a value or the minimum value of the given function. So in step number 4, using this x equal to a, we got the maximum value of the function, and if you substitute x equal to b, you will get minimum value of the function. So in step number 4 is all about obtaining the maximum and minimum value of function. Okay, so let's revise this entire second derivative test once again. So let's try to understand, so whether it's a maxima or minima. So please observe it very carefully, whether it's a maxima or minima. So please observe at extreme point. So I am talking about this point. The derivative is always equal to 0. So you will observe the derivative is always equal to 0, whether it's a question of maxima or minima. So right, okay. Then so they will provide you the function. So these are the steps that you have to follow for the maxima and minima. So obviously they will provide you the function. Let's say y equal to f of x is the given function. Then in step number 1, your job is to find its first derivative. So please observe, step number 1 is all about obtaining the first derivative. So right, so please find quickly f dash of x. And in step number 2, equate that first derivative equal to 0. What is the reason? The reason is simple. Whether it's a question of maxima or minima, the first derivative is always 0. At this maximum point, first derivative is 0. Even at this minimum point, this first derivative is 0. So anyhow, in step number 2, whether it's a question of maxima or minima, you have to equate this first derivative equal to 0. So now, as you are equating the derivative equal to 0, means you are getting some equation. So simplify it, and after simplification you will get one or two values of x. So let's say there are two values of x exist after simplification of this first derivative equal to 0. So then, since we got the two values, we don't know where exactly maxima or minima of the function occurs. So, right. So this step number 3 is very important one. And you will observe here why this is called second derivative test. The reason is quite simple. The second derivative decides where exactly maxima or minima occurs. So right. So already a first derivative is present in the step number 1. Quickly differentiate it one more time or find out its second derivative. And in that second derivative, substitute these two values of x. So substitute x equal to a in the second derivative, and also substitute x equal to b in the second derivative, and observe the final answer for the derivative. This is for just the sake of understanding. I assume, let's say for the x equal to a, second derivative value is negative. So friends, if the second derivative is negative, then a maxima occurs at x equal to a. This indicates function is maximum at x equal to a. So right, so this is the overall conclusion. So right, the next, if you substitute x equal to b in this second derivative over here, then let's say this is for just for the sake of understanding, I'm assuming let's say the value is positive. And if the second derivative value is positive, then we say, or the conclusion is, f of x is minimum at x equal to b, or minima occurs at x equal to b. Then the real task is to find the maximum and minimum value of function. So how to obtain that? We want a maximum or minimum value of function. So just start with the function, substitute x equal to a in it, obtain a final value. Substitute x equal to b in the given function and obtain the corresponding value. Since at x equal to a maxima occurs, you will observe that at x equal to a, it's a maximum value of function, and at x equal to b, you will observe it's a minimum value of function. So right. So overall, if you want to understand this thing using a graph, this is a tentative, not exact, but this is just for a sake of understanding. Let's say this is y-axis, this one is x-axis, and let's try to plot it, the meaning of this entire problem. So according to them, at x equal to a, maxima occurs, and at x equal to b, the function is minimum. So right, so let's say, so let me try in a one stroke. This is the thing. Okay, let's say this is the given function y equal to f of x. Let's say this is the given function y equal to f of x according to this theory. So whatever the things that we assume, so let's say this is x equal to a somewhere, and you will observe at x equal to a, the function is maximum. So this is the maximum value of the function. So right, so here we say f of a, which is a maximum value of this given function, and according to them, let's say as per this theoretical discussion, at x equal to b, the function is minimum, means at x equal to b, you will get minimum value of the function, that is f of b is minimum value of the function. So overall, without drawing a graph or without plotting it on the coordinate axis, just on the basis of the first derivative and second derivative, we can draw the simple conclusions. So where exactly this function is maximum or minimum. So friends, let's try to understand this thing using one simple example. So here I'm starting with a given function, and we have to find its maximum and minimum value using second derivative test. So the given function is, let's say, 2x cube minus 21x square plus 36x minus 20. So theoretically it looks little bit tricky, but if you start solving with the example, you will observe that it is very, very easy. So let's start with the step number 1. Step number 1 is all about finding a first derivative. So please observe, I am just following these 4 steps. So this is the step number 1 is all about finding first derivative. So right, so let's find first derivative of this. So keeping this 2 as it is, derivative of x cube is 3x square minus 21 times derivative of x square is 2x. Keeping this 36 as it is, so derivative of this x is 1 and derivative of this individual constant is 0. So finally the first derivative f dash of x is 6x square minus 42x plus 36, right? Okay, then the next thing is step number 2. So please observe the step number 2 of the question. So step number 2 of this maxima minima is all about equating this first derivative equal to 0. So let's equate this first derivative equal to 0 to obtain the maxima minima points. So here I am equating this first derivative. So let's write one sentence: at maxima or minima. So whether it's a maxima or minima, we have to equate that first derivative always equal to 0. So this is the first derivative. Let's equate that equal to 0. So it's a 6x square minus 42x plus 36 equal to 0. So let's take 6 common from this. So it's a x square minus 7x plus 6 equal to 0. The next thing is shift this 6. So on RHS, it merges with the 0. So finally, it's a quadratic equation: x square minus 7x plus 6 equal to 0. So friends, here we have to factorize this 6 such that the addition is minus 7. So obviously the factors are minus 6, minus 1. So here I am splitting this as x minus 6, x minus 1 equal to 0. So this will leads to 2 factors, either x minus 6 equal to 0 and the second possibility is x minus 1 equal to 0. This leads to the first value of x, that is x equal to 6, and the second value of x is, let's say, x equal to 1. So here I finished with the step number 2 where we got these 2 values of x equal to 6 and x equal to 1. So this is the step number 2 of maxima minima. So here we got this x equal to a and x equal to b. Then the next is step number 3. This is very important step. Step number 3 is all about obtaining the second derivative. So right, because the second derivative decides where exactly maxima or minima of the function occurs. So if you observe here, the second derivative decides the maxima and minima of the function. So therefore, let's try to find second derivative of the given function. So if you observe in this question, this one was the given function and this is the point where we got the first derivative in step number 1. So to obtain a second derivative, do one thing: simply differentiate this first derivative one more time with respect to x. So let's see. In step number 3, here I am starting with the first derivative f dash of x, which is already with us. It's a 6x square minus 42x plus 36. So it's a 6x square minus 42x plus 36. Let's find its second derivative, f double dash of x. I am keeping 6 as it is. Derivative of x square is 2x. Keeping minus 42 as it is, derivative of x is 1 and the derivative of 36 individual constant is 0. So here we got the second derivative, 12x minus 42. So finally we got the second derivative, and as the name suggests, this is called second derivative test. So once again I am repeating, here the second derivative will decide where exactly maxima and minima occurs. So we have 2 values of this x. So let's substitute that 2 values in second derivative. So let's say the first for x equal to 6, let's substitute this x equal to 6 in the double derivative. And let's cross check. It's a 12 into 6 minus 42. So is it 72 minus 42? So answer is obviously positive. So positive means f double dash of 6 is greater than 0. So what is your conclusion? So right. So at x equal to 6, what is your conclusion? Maxima or minima? If the second derivative is positive, then function is minimum at x equal to 6. So the conclusion is function is minimum at x equal to 6. This is the thing that you have to observe. So the overall conclusion is the function is minimum at x equal to 6. The reason is the second derivative is greater than 0 or it is positive. Okay, then we have one more value of x equal to 1. Substitute this x equal to 1 again in this second derivative. So f double dash of 1. I am substituting this x equal to 1 in the second derivative. It's a 12 into 1 minus 42. So what is your observation, friends? Obviously it's a negative. So overall it's a negative, means f double dash of 1 is less than 0. And if the second derivative is negative, then conclusion is function is maximum. Function is maximum at x equal to 1. This is the overall conclusion. So right, that's why this is called second derivative test. The reason is the second derivative decides where exactly maxima or minima occurs. Since at x equal to 6, if you observe, the derivative, second derivative was positive, so conclusion was function is minimum at x equal to 6. But here if you observe, for x equal to 1, this double derivative is less than 0 or negative, so the conclusion is function is maximum at x equal to 1. So here we finished with this very important step, that is step number 3, in which we clearly decided where exactly maxima and minima occur. So here we finished with this step number 3, and we got where exactly maxima and minima of the function occurs. Then the last step of the problem is finding finding maximum and minimum value of the function. So please observe this last step where we have to find the exact maximum and minimum value of the given function. So this is the given function. So right, this is the given function, and we want maximum and minimum value of this function. So let's start with this given function. So here I am mentioning this as step number 4. So let's start with the given function. So given function was, I think it was 2x cube minus 21x square plus 36x minus 20. This one was the given function. And in step number 3, the conclusion was at x equal to 6, it was minimum. So at x equal to 6, function is minimum. And at x equal to 1, the function is maximum. So if you want, you can cross check in the next step. So let's substitute these two values in this given function. So at x equal to 6, let's substitute x equal to 6 value here. So twice of 6 times x cube minus 21 times 6 square plus 36 times 6 minus 20. And whatever the value at x equal to 6 that you will get is obviously the minimum. So I am here mentioning whatever the value that you will get after this calculation is minimum. And the last step is also substitute x equal to 1 to find maximum value of the function. So see, since at x equal to 1, the function is maximum, so please substitute x equal to 1 here in this function. So twice of 1, its cube. I'm mentioning this as f max because function is maximum at x equal to 1. To find its maximum value, let's substitute x equal to 1 here in this function. It's a twice of 1, its cube, minus 21 times 1 square plus 36 into 1 minus 20, and whatever the value that you will get is the maximum value of the function. So that's all, friends. This is all about deciding where exactly the maxima or minima of the function occurs. And in step number 4, we also got the maximum and minimum value of the function. So right, so in question of maxima and minima, every time you have to follow 4 steps. Try to understand, you have to follow 4 steps in the problem. So please observe this. So this is the given function. They will provide you this given function. Then in step number 1, quickly find out the first derivative, right? And whether it's a maxima or minima. In step number 2, whether it's a maxima or minima, equate that first derivative equal to 0, because at extreme point or at maxima or minima, the first derivative is always 0. And if you equate the first derivative equal to 0, you will get 1 or 2 values of x. So if you observe, so you will get 2 values of x. So here we got the first value x equal to 6 and second value x equal to 1. But we don't know where exactly maxima or minima occurs, whether it is at x equal to 1 or x equal to 6. So that confusion is cleared in this step number 3. So step number 3 is all about finding the double derivative. For the first derivative is already with you. So this is the first derivative. Just quickly find out its second derivative, and as the name suggests, it's a second derivative test. So here the second derivative will decide where exactly maxima and minima occurs. So we got these 2 values of x. So substitute x equal to 6 and x equal to 1 in the second derivative, and observe the final answer of the second derivative. So if you observe here in this example, we got second derivative positive for this x equal to 6. Means the conclusion is function is minimum at x equal to 6. So understand this, if the double derivative is positive, then the function is minimum at that point. And if you substitute this x equal to 1, at the end we got double derivative negative, and if the double derivative is negative, then we say maximum occurs at that point x equal to 1. So overall in this step number 3, we got these 2 conclusions. The function is minimum at x equal to 6 and it is maximum at x equal to 1, but we don't know the value of the function. So therefore in step number 4, I started with the function, and in that function please substitute this x equal to 6, that will leads to the minimum value of function, because there was a minima at x equal to 6. And if you substitute x equal to 1 in the given function, you will get maximum value of the function. So these are the 4 steps that you have to follow in any maxima and minima problem. So I hope at least this